Testing an emergency pull cord system. The bottom of the pull cord can be no higher than 6 inches. If the bottom is higher than 6 inches, it needs to be extended or the pull cord needs to be replaced. The easiest way to do this is to mount it in the center of the trim. The emergency pull cord can also not touch the floor. When the cord is pulled, it pushes the switch down or pulls the switch down and sets off your siren and strobe located in the hallway or the exterior. If your outdoor siren doesn't sound and the light does not flash, we need to locate your issue. If you have more than one pull cord in the unit, test the other ones to see if the siren will sound. If it sounds with all other pull cords except for the one we were previously on, then we know we can focus our attention to that one switch. If it does not sound with any pull cords in the unit, then we would locate our transformer. Transformers are usually located in hallways, close to the ceiling. In AC closets, usually mounted on the left or right side, on the wall, or in a bedroom outlet with a plug-in style transformer, similar to the one pictured. When the transformer is located in the hallway, there will usually be a double gang blank close to the ceiling. We will remove the 4 screws and then remove the cover. After removing the screws and before pulling the cover off, take your knife and score around the edges. This will keep the paint from pulling off with the cover. Get your meter and set it to NCV, non-contact voltage. With the cover removed, use your meter and touch your main lines coming in, not your small low volt wires. Come to your breaker panel to see if you have a label This one does not have one that is marked for the emergency pull cords. So we would start with our 20s one at a time. We would cut a 20 off. And we would go back and we see that we still have power. We would continue this until we find out which breaker it is. We can cut this breaker back on. We can go in a set order so we don't get confused. Once the proper breaker is located, we can leave this off for now. While the breaker is off, we can remove our transformer, leaving the wires attached, separating the wires and making sure there's nothing touching any metal or anything that could possibly cause a short. Once we verified that no wires are touching, we can return power to our transformer. On our transformer, we can see our 2 low voltage wires. In this case, we're using black and red. We have a third white that is rolled up that's not being used on the low volt side. And on the back side, we will have our line, neutral, and ground. Setting our multimeter to VAC. You can use the amp clamp to secure your multimeter to a door or something similar, or use the magnet on the back so you can have both hands to test these wires. Find your neutral white and your line coming from the breaker. Take your wire nuts and fold them back at an angle away from you to where you can see the inside of the wire nut. This will give you a place to test your multimeter without having to remove the wire nuts. Using the red lead of our multimeter and the black lead of our multimeter, our black we can go to ground. Our red will go in the wire nut, ensuring we get a proper connection, and we'll verify we're getting 120 volts. This is a universal transformer that goes from 16 to 30 volts. Wiring it to here would be 16 volts, and we have it wired to 30, so we know that we are looking for around 30 volts of power between these two low voltage lines. Using our multimeter still set to VAC, we will test between the red and the black low voltage line. We were looking for around 30 volts. Testing between these two, we have 28.42. Right at 30 volts. Now we need to test the low voltage side of this transformer while it's under load, which means activating our audio-visual siren with the pull cord. We would activate our pull cord by pulling the string or flipping the switch. And with our pull cord activated, we would test the voltage between our two low voltage wires, these red and black, again, and see if our voltage drops. If the voltage drops, we know we're sending a load out, so our switch is working and it is calling for that siren to activate. So with our voltage dropped, we will go and remove the siren from the ceiling outside. On this style siren, the plastic cover simply pulls straight down, exposing two screws to remove the mount. Pulling straight down, you can see the two screws holding this to the ceiling. We remove these two screws. The wiring varies on these, but usually you will have two wires going to your light and two wires going to your siren. These can be followed up, white and black here for your light, and then you have black and black for your strobe, for your siren. You can follow your two blacks to see where we're tied into. We're tied into a cluster, and this is coming back from our transformer. So we have one from our siren, our second from our siren. We have one going to our black load and one going to the red load here. Using our multimeter set to VAC, we will test between this black and this red to see if we're getting our 28 volts out here. We're getting our 28 volts between these two, but our siren is not sounding and our light is not activating, then we know that we have a bad cluster. Typically it would be the light doesn't come on but the siren sounds, or the siren doesn't sound and the light comes on. In that case, if you had power going to this and your siren sounded but your light didn't come on, this style has a replaceable bulb. A lot of the newer styles are integrated and you would have to replace this whole head. If your strobe is bad, then you would replace this whole head as well. The switch activated, if you are not getting a voltage drop at your transformer, then we will go and troubleshoot the switch. Removing the two screws and remembering to score around this so we do not bring the paint with us, we can remove this faceplate. With our faceplate now turned the right way, and the screws removed, we can remove this, exposing our wires in the back of our switch. First, we would inspect here for any broken wires or broken ends. We would check for a loose connection on our wire nuts, make sure everything is secure. We would fold our wire nuts back, and we would test to see if we were getting our 28 volts at these two wire nuts. Once we verify that we are getting the 28 at our connections, we'll verify that we're getting the 28 volts at our switch. We test between the two black wires and our white wire. If you're not getting 28 across this switch, then your switch is bad. This unit only has one run of low volt wire in each junction box for each emergency pull cord switch. The junction for these is out in the hallway behind our strobe where you've seen that big mess of wires. However, some units will have two runs of your low volt to where they pigtail off of this switch, which means you need to test each switch in your unit to verify they're all working. If you have one that is pigtailed and it is sending the power from this switch to the next switch, if this switch is bad, then that would cause your siren not to strobe. Just a quick recap. If we have 120 main coming into our transformer and we have our, in this case, close to 30 volts coming out, then our transformer is good. If we have the power in and out through the transformer and we do not have power to our switch, we have power to our switch, but we don't have power out of our switch, then we know the switch is bad and needs to be replaced. If we have power in and out of the transformer, in and out of the switch, and we have power going to the strobe right at the wire nut connection, but our siren and strobe is not sounding or flashing or lighting up, then we know we need to replace that siren and strobe. If the siren's activating and the light is not lighting up, then we can see if we can replace that bulb. If the bulb is integrated, we need to replace the whole siren and strobe. If your light is lighting up, but the strobe is not sounding and you verified you have power, then you need to replace your siren and strobe as well. On some emergency pull cord systems, you will have a plug-in style instead of a standard transformer that simply looks like a plug that someone cut the end of the wires to. On these, we need to check, read them and verify if they are switching adapters or switching converters, which would mean it would turn this AC into DC.
So on this one, we can see that it is a switching adapter, which takes 100, 240 volt input, and it outputs it at 6 volt. If you notice the difference in the symbols there, the one after 240 volt is a wavy symbol, which indicates it's an alternating current, AC. The output of 6 volt is the line with the dots, indicating it is direct, DC. So, not only does this transform the power into a smaller voltage, it also switches it from AC to DC.
If you have these style plugs, they will be, they will usually be located in your HVAC closet, mechanical closet, or similar, and they would have a plug, and then they would have a blank usually, and behind that blank would be where these wires go into and your wire nuts attached to send it onto your switches and your strobe. For this one, to test this one, with it switching from 120 AC to 6 volt DC, sorry, we would start with our meter in VAC, alternating current. We will first test our outlet with our multimeter to VAC, alternating current, to verify that we are getting our 120 to our outlet. Once we have verified we have the 120 to our outlet, we will take our multimeter and we will switch it to DC, direct current. We know that we read on this plug that its output is 6 volt DC, so we are looking for roughly around 6 volt DC at our plug. This plug is for reference, as most of these will be 12 volt DC if you do have a converter that switches to DC. But for the training video, if we would have only had 1 or 2, 3 volts coming out of this, we would know that this is bad. The same way if it was a 12 volt that should send out 12 volt and you're testing close to that plug and you're only getting a couple volts, then you know it's bad. DC voltage, the longer it travels, the more voltage drop you have. So if you're having very low voltage this close to that plug, then that plug needs to be replaced. If we verified, you know, we have our 120 at this plug and we are not getting any reading in DC on the end of this, then this plug is bad. Everything else after this would be identical to the previous steps in the video.